everyone, and welcome back to another video on our series Building an Autonomous Robot from Scratch, which is a differential drive robot, which is this one here, and we call it Perceptron bot. So in this video we will be basically finishing up the low-level development part by developing this serial protocol that will be used to then communicate with the onboard PC, like the Raspberry Pi. And then after this episode, we will only be focusing on ROS development mainly. And so essentially we will be making the robot autonomous using the Navigation 2 framework. But so for this episode, we will be developing this serial protocol. And the main idea is that we will have this command that it will initialize itself with a flag that will tell us what exactly the command we want. And eventually after the flag, we will have, for example, some values for the left motor or the right motor or anything else really. So to start with, let's create another file here called serial protocol .gpp, and in the source as well a serial underscore protocol .cpp. And usually we always define this boilerplate code. If not defined, serial protocol HTTP define serial protocol HTTP. Okay. So I will be doing a class as well. Now this doesn't necessarily need a class, but maybe for the future it's nice to have one. So yeah, let's just include the Arduino library. We will also need the motor controller library, or in this case header file. And so that's that. And now we need to create a enum which will define basically the flags I was mentioning. So type define enum, and then let's call it flag codes. What did I call it? Flags. Okay, and so we will have four different flags. Yes, so we will have a flag called C, which will be for closed loop control. So flag closed, close equals C. Then we have another flag open, exactly. And then so O for open loop. Essentially we will pass in PWM values. We will have flag for odometry, or the pose of the robot, which we will use the letter Q, and flag motor status as an M. Okay, cool. So essentially the command will look like this. We will have a flag, then for example for the open loop we will have a left PWM, then a right PWM, separated by the spaces. Okay, so now let's create the class serial protocol. Public, we will need the serial protocol constructor, and we will need to pass in the motor controller as a pointer, because we will use it to then, for example, pass the velocity commands and so on. We will also need a function void read serial or serial read. Read serial is the one I call it. Then we have some private ones. So we will have a void send ACK, which is for acknowledgement, and this will this will take in a code. We will have then a function parse cmd for the command, and we will need to pass in a string of the command. And then we will need also a object for the motor controller. So motor controller, a pointer, motor controller. This will be a private. Okay. Yeah. And I forgot here we need to pass it the reference. Cool. So essentially the read serial will check if there is something to read from the serial first, and then it will write basically everything into a buffer. And we know that it has finished once we have seen a line break, so that \n. And then in the read serial, it will call this parse command function, which then will accept this buffer that we gathered, and it will try to match any of the commands we will have. If we don't match any, then it means that either the command is invalid or the command is not in the correct form. And then the send acknowledgement is just a way that we can send back a message. Like, for example, if the command is invalid, we could send error or something like this. So actually, yeah, the parse command also returns an integer, which will be basically the return code, right? Okay. So let's create now the actual code. So we include serial protocol, and we will then initialize the constructors. So serial protocol, which takes the motor controller like so and initializes it. That's that. Then for the serial, so void serial protocol with serial, and it's not like this, right? So what does this do? Well, if the serial line is available, meaning if there's something on the serial connection, right, we will want to basically get the line, right? And so it's already showing me the copilot here. So we basically store in the buffer the string right here, and this will break once we find a \n, so the break line. And now we will pass this command to the parse command, which will return us a code, and then we will send an acknowledgement back. And now the void serial protocol send ACK in code. So now it will not be this, but we will have a switch case, which is the code. And then in case the code is, now I need to see what I wrote before. So in case it's a 0, we will simply say serial.print line okay. So everything was okay, and the requested command was executed, right? So the next one, case equals 1. So basically any positive number will be a positive acknowledgement. Any negative number will be some error that happened. So here in case we have a 1, why do we want this? And the case is for basically when we want to get some data, for example, the pose, we don't want to send an OK, because it might then confuse when we read something from the other side, that we might miss the actual message. And since in the case of the geometry, we are already sending something, it is kind of a proof that it worked, I guess. So that's that. Now, in case we have a -1, we will serial print error, and we will be more specific, invalid command. And then we break, and then we copy this, and we have a -2, and the -2 is basically for the open loop. We say that PWM values are out of the range, yeah, out of range, and then another one for -3, or actually this would be the default value. The command is unknown, basically. Unknown command. Okay. So I think this is basically explanatory, I guess. So now comes the main function, which is not a void, it's an integer. Serial protocol parse the command, which is a string command, and then this. Okay. Cool. So let me see what I have here. So first we will say, well, what is the flag, right? And it is exactly this, and we will return a -1 in case we reach this point here, right? It's saying that this parse command is not matching. Oh yeah, of course. Okay. Now we need to do another switch case for the flag. Now we basically just go through the enum values we have. So we have a flag open, or in this case close. Then we will say basically here send cmd velocity. So break. We will do this after. We need another case for flag open, and then here basically we will send PWM values. So break case flag pose. Here we will send the odometry / pose. Break, and then another case for the flag motor status, then send motor status, and then bus break, and then the default is return -1. So essentially we will never reach this thing here, so cool. So what can we do here? So essentially now we need to pass the type of command, right? And for this we can use the scanf function. Now the way it works is, well, you basically type in a let's say, a pattern that you want it to figure out, and it will return you basically the values you want. So what we do is, well, scanf like this, and then we type basically the flags, so C space, and then we will use DD, yeah. So D and then D, and it's not for PWM, but it will be for X basically. So let's create here X and then W. So this, and then we will say reference X and the reference W, and we will check if it's equal to 2, right? And basically the 2 means the scanf actually received 2 values. Just let me be sure here. Yes. Oh yeah, of course we are missing the important part, the CMD. We are missing here the CMD, and we need to make it C string. Okay. Now what do we do here? Well, simply we say motor controller dot send command velocity, and now the command velocity, well, it was X and W, right? It is a structure flex. So if I go to motor controller, sorry, the HVP, not this controller HVP, here we will have the command velocity structure, right? It's an X, so the linear velocity and the angular velocity. Cool. Now the reason it's complaining here, and that is because it's supposed to be a float number, and here we are using integers. And the reason why is because I tried using the floats here, but it was not working as basically it was always giving nothing. So what I decided is, well, instead of using 0 from -1 to 1, we will use it from -1000 to 1000. And so here we will still need to basically say that this will be divided by 1000 and this divided by 1000, 0.0, 0.0. And this is not working. So let's do the following. Well, let's create a CMD val, CMD underscore velocity. Now let's say that CMD val.x is equal to x divided by 1000. And then the W is the W divided by 1000 as well. And then here, not there, we will say CMD velocity, like so. And that way we have only integers here, right? And that way is good. So basically now we copy paste this and we put it here on the flag open, and let's change this to be left PWM and then right PWM, and then here it will be a uint 8, left PWM and right PWM. Now I have changed the motor controller to also accept PWM values, so that's why I can do this here. And so if exactly, that's already there basically. So it's not set PWM, but it's oh, I did not pull the latest changes. But basically there is a set PWM in the motor controller that is on the main branch, which is not the one I am, and so you will be passing the values here like this. But I don't really have it right now, so I can't show you here. But if you look into the GitHub repo, you will see that this will be updated. Okay. So now for the flag pose, we will do just, so if it was a flag, basically we just need to send the data. And so we do serial protocol, no, not serial protocol, serial.print, and then we will send, so motor controller dot get pose. Now we need the pose. So the pose, you need to pass the reference here. Oh, never mind. Sorry. Okay, like so, and then we do serial dot print, and now we will say pose dot x serial print this exactly, and then pose dot y and pose dot theta, and this one is a print line. Okay. Now for the motor status, it will be the same as this here, but since I also don't have here the code, it will be calling motor controller, and then get motor data. And so here you need to pass the data variable, and then basically do this printing. Okay. But again, I don't really have the code right now here. But that doesn't really matter, because what is interesting for us is both the flag close and the flag pose. Okay. And I believe this is done actually. So now we just go to the main .cpp, and then we will create here. First we need to import, include serial protocol. Now let's create here a serial protocol. There we go, and we pass the motor controller. Let's remove this thing because this was from the previous video, it was the test. Let's move this. Let's remove this, and now let's do serial protocol dot read serial, and that should work essentially. So to test, let's do PO run. So you can use the VS Code. That is something from here included for me, even though I didn't set to. And there we go. Okay. So now I do have a script that I used ChatGPT to get it. Test serial.py, and it worked wonderfully. So I will leave this in the description. I mean, sorry, not in the description. There will be a folder here called scripts, which will have this script right here. You just need to make sure you change this here to your correct port. If you are on Windows, you will most likely be using some COM number, and if it's Linux, and it should be /dev/tty and then something. And also make sure that this number here is the same as we have in the configuration for the serial baud rate, right? If you change this, be sure to change this as well here. Okay. So let's run this Python test serial test, and fingers crossed it works. So now we can use, as you can see, we have closed loop mode, open loop mode, which is not working, and the motor status is also not working. but we can send the, for example, 3 to get the odometry data, and 3 again. So yeah, I mean, this is not perfect. This is the first message it's sent, so that's why. So here we have the x, y, and theta. Now if we send a 1, we need to enter the velocity, so I will say 100 for 0.1, and I will say 0 for 0, and then error, invalid command. So why is it not working? Alrighty, so I found a mistake. Basically I forgot here this S, so it's SS kind of F, and also I forgot the return code here, 0. And on that note, we also should return a 0 here, and here we should return a 1, and here return a 1. Okay, so now also let me remove from the main the start. Let's remove this and let's push again. All right. Okay, so let's do 1, 100, 0, and indeed it is moving. And so we can now check the odometry, and you can see also the response. So it was an okay response. So if you check odometry, you see that it is moving. I mean, I set it to go forward, and you can see already that it's, I mean, not just the X that it's going, but yeah, it's slightly going to the left a bit. So yeah, then we can send a 0, for example, to stop the motors. And this is essentially how we will control the robot using ROS, basically. And so we will create the nodes, and then basically do this serial thingy we are doing here to communicate between Arduino and the Raspberry Pi. But yeah, that was a very simple protocol, just a few lines of code. And yeah, so in the future we can improve this, of course, to make it more, I mean, to have more flags for something else. I don't know, for example, battery, we might have some sensor to read the battery voltage and so on, the current as well, but that can come later. So yeah, that's it. If you have enjoyed this video, subscribe and give a like, and yeah, comment if you have some doubts or questions, and I will try to answer them. If not, then see you on the next one.